Hello students, welcome back to my channel. Let us continue learning the lesson data structure. So we have already completed arrays. Today we are starting to learn a new type of a data structure which is stacks. Okay. So what is this stacks is all about? Okay, a stack is an ordered collection of items where the addition of new item and the removal of the existing items always takes place at the same end. Now what is this meaning? Suppose you have seen a bucket in your house, isn't it? Now, how do you fill water? You fill it from this opening, and then how do you remove water from that? You always remove it from this end, isn't it? Now, this part is always closed. There is no possibility that you can add or remove water from this side, isn't it? Now, in the similar way, how our stacks work. Now, this particular sentence is saying that a stack is nothing but an ordered collection of items where the addition of a new items and the removal of the existing items always takes place at the same end. So in the stack, we always add item from here and we always remove item from here. Okay. So this end is commonly referred to as a top. So this particular part where we add and remove data is called as a top and the opposite side is called as a base. So whenever we are saying stack, you should always remember something like this. And there is only one opening. And then we are adding and removing data items from that particular opening. Okay. So the most recently added item is the one that is in the position to be removed first. So if we are considering our array, we have already learned array, isn't it? How does that look? We always use a subscript as a of 0, a of 1, and then we increment it and we keep adding data item like this, isn't it? Now in this stack, what is happening is first I will add 1 here. Okay. Now on top of that, if I have to add 2, I will add 2 here. Now then I will add 3. Now suppose I want to remove this. If I want to remove 2 from here, then first I have to remove 3. Only then I can remove 2. Okay, so that is what they are saying. The most recently added item is the one that is in the position to be removed first. Okay, so if you want to remove any data item in your stack, so whether it is this, whether it is this, whether it is this, the one which is on top or one which is added recently. Now this one is added recently, isn't it? First we have to remove that, only then we can go further. So this ordering principle is sometimes called LIFO or last in first out, which means since I have added this particular item last, that only has to be removed first. So that is what last in first out, which is the first in. We added this first, but then we are going to remove that last. Whichever has removed last is going to be removed first. So that is what this LIFO means. Now, newer items are near the top while the older items are at the base. Okay. So, whichever we are adding in the beginning, that is going to come at the near the base, and whichever we are going on adding. So, as and when we are adding, it is going to come to the top. So, the newer items are near the top and the old items are always at the base. Right. So, if I have to show you some real life example, look at this. Can you see this? These are the things commonly we see in everyday life, isn't it? A pile of plate in our kitchen or in the restaurant. So what happens? Can you directly remove a plate from here? What is going to happen? Rest of them are going to fall down, isn't it? They're all going to break. So how do we remove it? We carefully remove one by one, isn't it? So this is what the logic we use in stack also. So while doing this pile, how you would have done it? First, you would have kept this plate, isn't it? And then you would have kept this. But when you're removing, what is happening? Whichever you have added last, you're going to remove first, isn't it? Now, similarly, see here. Even in this case, you have to be very careful because these are eggs are going to break, isn't it? So when you're piling it up, as and when you're piling, the first one is going to come to the last always. And whichever you're piling at the last is going to come on top. Now, if you want to remove this, suppose if you want to remove this fifth one, then what is going to happen? First, you will remove the latest one. Right now, you added this. Now you remember, okay, suddenly I want this particular tray. Then what you're going to do? You're going to remove it in this order, isn't it? In this order, you're going to remove. So the same logic is going to get used in the stack. So this kind of example you will see in everyday life very commonly, like a stack of trays, stack of books on your desk, etc. And also This same kind of a thing is used in your backtracking. You would have seen whenever you are doing a Google search or something, you will go to one page. From there, you will click another link and you go to the next page. But then you will realize that that was there in 5 pages back. Then what do? You go to the back page, isn't it? So in that, what is going to happen is they are going to keep every page in the stack. Okay, this is one of the application. So when you say back, what is going to happen? This is going to get removed and you're going to come over here. Again, you say back, this particular page is going to get removed and you're coming to the next page. So when you say back, every time that page is going to get removed and you are going to come into the previous page. So that is how a stack works in a real life scenario also. Okay, so see this image, it will be more clear. So this is my stack. I will always have a pointer saying top, which points at the top element. Okay, so when I know that my top is here, I know that I can increment the top and add another item here. Now adding another item in terms of data structure or in terms of stack is called as a push operation. So this push operation is nothing but insertion. Okay, now if I want to remove one data item from here, suppose I want to remove it, then we are going to say, suppose I'm removing element 6, then what I'm going to say, I'm going to do the pop operation. So pop operation is nothing but deletion or remove. Okay, removal or deletion is called as a pop operation in stack, and insertion or addition is called as a push operation in stacks. Okay, so see here LIFO, last in first out. So stacks always work in last in first out, as in I have added this particular data item at last, but that is the one which is going to be removed first. Clear? So how do we represent this stack? How do we represent this stack in a memory? Arrays, we know that we represent in a contiguous memory location. So how are we going to represent these stacks in the memory? Now the stacks can be represented using arrays and linked list. We have already seen in advantages of arrays that we use them to represent or implement stacks, isn't it? So this is what it means. Now here we are saying that static representation using arrays. Now what does this static means? Static is nothing but fixed. Okay, if you are representing our stack using the arrays, then that is going to be fixed, because we know that arrays cannot be changed, or the size of the arrays cannot be changed during the execution, isn't it? So that is why this is a fixed representation. If at all you want a dynamic as in which keeps changing, okay, changing, then the dynamic representation using linked list. Now what is this linked list? We are going to learn in detail in the coming sessions about linked list, but briefly today we are going to learn a little bit about them. Okay, so remember there are two types of representation of stacks in the memory. One is a static representation using arrays. Another one is a dynamic representation using linked list. Now let us see what is this static representation. Okay, so stack can be represented using one-dimensional array. Here, you should remember that one-dimensional array looks something like this. In both linked list representation as well as array representation, I'm going to show you how does an array or a linked list looks like, but how are we going to imagine or logically represent that stack? Okay. So now I know that my stack looks something like this, and I'm going to go on add element like this, isn't it? So, and also the top is going to be here initially, as in when I'm adding, the top value also going to get increased, because top always represent the latest item, or it is always pointing at the latest element, right? Suppose I have this 1, 2, 3, then top is going to say that this is the first, second, third. So suppose it's 10, 20, 30, then top is going to be 3, because how many elements are there? There are 3 elements, right? Now similarly, we are going to have a pointer in our array which will say top, and as and when I'm going to insert the value, that is a of 0 is equal to 1, a of 0, okay, this is 10, a of 1, I'm going to say 20, a of 2, I'm going to say 30. Okay, so as and when we are adding value, I'm going to increment my top value also. Now top is going to be this subscript. So that is nothing but 3 it is going to be, right? So this is how, this is the actual representation in the memory, and this is my logical representation, right? Now next, see here, stack can be represented using one-dimensional array. A pointer top contains the location of the top element of the stack. Okay, so always the top will be pointing at the top element or the latest element. Now we are also going to use a variable called as max stack. As you can understand, this is nothing but it is going to hold the maximum number of elements a stack can have. So this is nothing but maximum number of elements. Okay, suppose I am going to declare an array A of 5 to represent a stack, then maximum number of element it can hold is 6, isn't it? So what is going to be the max stack value? The max stack value is going to be 6, right? So 6 elements I can hold in this particular stack. So that is what we are saying here. Max stack contains the maximum number of elements that can be stored in that stack. Now look at this condition. Top is equal to max stack. What do you understand by this? This is nothing but top element always points to the top element, and max stack is nothing but the maximum number of stock. This means that my stock is full. How is that? Suppose my max stack value is 6 and I have 1, 2, 3, 4, 5, 6 elements. So in this case, where the top will be pointing, it will be pointing here. And what will be its value? 1, 2, 3, 4, 5, 6, isn't it? Now top is 6, max stack is 6, and both are same. So this condition is going to become true. This means that I cannot have any more data items added into the stack. Why? Because this is an array representation and my array is of only size 5 and it can have only 6 data items. And we know that arrays cannot be dynamically increased during the execution. So that is why we are always going to have a max stack, which will keep the count of the maximum number of elements, and top anyways points at the top element. When we compare them, if at all they both are same, which means we are going to say that the top is stack is full. So this condition gets satisfied. So when stack is full, we cannot do any more insertion into that particular stack. Okay. I hope this is clear about stack is full. Now, if I say top is equal to null, what does this mean? I have a stack and my top is here. And since there are no element in this, this is equal to null. This is nothing but stack is empty. Now, these two conditions are very, very important if when you write a code or a program using a stack, because if these we don't check for these conditions, then your program may throw an error. So if at all you're representing your stack using a one-dimensional array, then these two checks has to be done. Okay. So in the first thing we are checking if the stack is full. In that case, we cannot do insertion into the stack. We cannot add any more element. And in the second case, we are checking if the stack is empty. Why do we need to check stack is empty? If at all you're doing a deletion operation and if there is no element here, then if you do a deletion, then it is a problem because there are no element and then you're trying to do a deletion, isn't it? Now, representing a stack using array is easy and convenient, useful for fixed size stacks. So we can represent the stack using the array only when we want to represent a fixed size stack only, not otherwise. Okay. So if you want an array, if you want a stack which has to change the size during the execution, then you cannot represent it using array. So in such cases, we have something called as a linked list. Okay. So see here, this is the same thing what I explained. This is the array representation of the stack. So this is our array. These are our subscript. Okay. So top pointer is pointing at the latest item because 2 is added. Suppose I add one more, then I'm going to move my top over here. Now, how is it logically represented? Something like this. First, we will have an empty stack. As we are adding one is going to come and get stored at the bottom. And then we will add 2. It is going to come get stored on top of that. And if I want to remove 2, this will be removed first. Even if you want to remove 1 in this case, then also you have to remove 2. Only then you can remove 1. Okay. I hope this is clear. So next we have linked list representation of the stack. Now what does that mean? Now in linked list, we can increase the size at runtime by creating the new node. Okay. So what is this node? What is this linked list? It might be a little confusing. Let me brief you. Okay. Now linked list is always represented like this, where we are going to have a head, okay, and it is going to have a address. Now this address is pointing at the next node. Now each data item is stored at a node, so these are called as node, right? Now what does a node has? A node always has two partitions, okay. One part will have the data, another part will have the address. Address of who? Address of the next node. So see here it is saying 4900, and where it is, the 4900 is here. So this is the node. Now in this node, this is the data item, and the address part has 5000. Where is 5000? 5000 is over here. Now when I come to 5000, here also I have another node, and the data item is 5, and this also has the address 3000. Now where is this 3000? 3000 is here. Now this is also representing another node, and it has 20 as a data item, but here the address part has null. What does this mean? Now whenever you have a null in the address part, this means that this is the last node. There is no more nodes after this. So this is the end node. So this is what a linked list means. So linked list is always represented with a node with two parts. One has a data item, another one has the address of the next node. So whenever it has the address of a next node, we always say that they are connected like this. Clear? Right. Now, see this insertion operation. So how do we perform an insertion operation in our stack, and how do we represent that in the linked list? So insertion operation refers to inserting an element into the stack, which we already know, isn't it? We create a new node and insert an element into the stack. So how do we insert an element when we are representing it using the node or a linked list? What we do is we have a head here, and then I say create another node. So when I say another node, suppose this already I have, then I'm going to have another node created. Beforehand it was null here. Why? Because only these many things we had. Now what I'm going to do is I'm going to remove this null, and suppose 1000 is the address of this particular node, then I'm going to say 1000. So when I say that, automatically this node is going to get linked to the another node. This is how I have created another data. Suppose I already have one here. I want to push 2 into this. Then 1 is over here. I am pushing 2 into this. How? I am going to store the address of this particular over here. So by doing this, I am going to create another node. Okay, I'm creating another node, and I'm going to link it to the linked list at the end. That is very important. See here, to follow the stack principle, last in, first out. So last in, first out. 2 is getting added at the last, and we are going to remove it first. A node need to be created from the end of the linked list. So you cannot create a node over here. You cannot create anywhere else. It has to be at the end. So wherever there is null, we are going to remove that null and add the address of the new node, right? Now, elements need to be inserted into the node from the end of the linked list. And why we are doing that? In order to keep the last in, first out principle of the stack. Right. I hope this is clear. Now this is the stack representation, and this is the linked list representation. So in stack, how does it look? It looks something like this. We already have 1 and we are pushing 2. But actually in linked list, what is going to happen? We have a node here. We are going to create another node and store the whatever the data item we are pushing into the stack and get it linked to the end of the linked list. Clear? Now, next operation which we are going to perform is deletion. How do we perform deletion operation using linked list in stack? So how does it work in a stack? Suppose I have 1, 2, and I have 3, and I have to remove this. This is removing is nothing but pop or deletion. Okay. So how do I perform? So how can I represent this particular stack in the linked list? I will have 1 here. I have a start, and then I have this. Suppose 1000 is my address of the next node. Okay. So then I have 2 here. So this is nothing but my this one. Okay. So this is Suppose this is storing 2000. So this is the address 2000. So this particular node is nothing but this one. Okay. And here I have 3 and this is nothing but this particular data item. Now I want to remove this 3. So how am I going to do? So see here, since 3 is the last node, I'm always going to have null here, isn't it? Now, in order to remove the link between these two, isn't it? That's what I want to do. I want to remove this link and I want to have only this left. So I am going to remove the address part of this node and I am going to fill in what here? I am going to say null here. So whenever I say that, automatically the link between this node and this node is removed. Now we are left with only this. So which in other words, I have removed this 3 or I have deleted, right? So deletion is an operation to delete an element or the node from the linked list. Deletion can be done by deleting the topmost item. So we have to remove the topmost item. So in other words, in linked list, we have to remove the last item. Okay. So the recently inserted item, that is a top item, must be deleted from the linked list to perform the task deletion. So that is why we always say insertion, always do it at the end so that we know that that is a recent one. So in case of deletion also, we are going to remove the last element, right? I hope this insertion and deletion operations are clear. Now next we have set of operations which we perform on stack. What are those? First one is a stack. So when we use this particular operation, we are going to create an empty stack, right? Next is a push of item. So if I'm saying push 1 here, so what I'm going to do, I'm going to push 1. This is nothing but I'm going to adds a new item on top of the stack. So top initially, of course, it will be equal to base. As and when I'm adding, the top is going to get increased. So push operation is to add an item. Pop operation is to delete an item. So if I say pop, whichever is on top is going to get deleted, right? Peek returns the top item from the stack but does not remove it. Suppose I have here 2, 3 and top will be pointing over here. Now when I say peek here, it is going to return 3. Okay. So it is going to return the top item. It is not going to remove it. It is just giving us the information about which is on top of the stack, right? Is empty. It is going to test whether our stack is empty. So in this case, it is going to remove, it is going to return the value false. And if I have just a simple stack or empty stack, then it is going to give the value true. So it always gives Boolean value. Okay. Next is size. Now what does this say? It returns the number of items on the stack. It needs no parameter and returns an integer. So in this case, size of this particular stack, it is going to return 3. Okay. So in this particular case, it is going to return 0 because there are no data items in that. So it is going to return an integer value. So today we have seen what is stack, how do we represent them using 2 methods, and also various operations we perform on stack. In the next coming session, we are going to learn the 2 algorithms, which is push and pop. And also we are going to see what are the applications of the stack, right? Till then, thank you for watching, students. Take care.